Problem 15 has multiple steps to it. So let's jump right in. This is our skeleton of the equation that it has. It said that write the equation for hydrogen with nitrogen, so hydrogen with nitrogen to form ammonia. And the only formula I gave you was ammonia. We have to remember hydrogen and nitrogen, those are atoms. And in the problem, we're not talking about the atoms, we're talking about the molecules. So both of these are diatomic molecules. That will make a huge difference when we go to balance our equation. So let's go ahead and do our inventory of our atoms. We have 2 hydrogens, we have 2 nitrogens on the reactant side. On the product side, we have 3 hydrogens and 1 nitrogen. So we got to get these balanced. Well, nitrogen, we definitely have to up it. 3 is an odd number, so we need to get this to be an even number. So let's plug a 2 in here. By plugging a 2 in there, 2 times this 1 for nitrogen now makes this 2. 2 times 3 is going to make this 6. All right. So our nitrogens are balanced. Our hydrogen is not. So 2 goes into 6. How many times? 3 times. So if we plug a 3 in here, we now get 3 times 2. That's our 6. We notice our hydrogen is balanced. Our nitrogen is now balanced. We have a balanced equation. Let's plug 1 in there. Okay. Now, the next part of the problem asks us to start with 30 grams of hydrogen. And remember, it's H2. And it wants to know how many liters of ammonia are going to be produced. Okay, so we're going to go through this quick. We don't want grams, so grams of hydrogen automatically come down. We already know that's going to equal to 1 mole of the same substance, which is hydrogen. We don't want moles of hydrogen, so mole, hydrogen. And now this is where we do our change from a molecule. So we have moles of NH3. Now the numbers here are going to be our coefficients. So moles of hydrogen, we're going to look up here for our coefficient. We have 3 of those. And we're going to look over at our ammonia, and we have 2 there. Okay, we still don't want moles of ammonia, so we're going to put mole of ammonia, and we know it's going to be 1 is going to equal to liters of ammonia, and that is 22.4 no matter what. Okay, so the only thing we have to do, we plugged all the numbers in except for the grams of hydrogen. So we got to use our periodic table. We got to look up hydrogen. Hydrogen has a mass of 1, but there are 2 of them. So 1 times 2 is 2. Okay, now we're done. Grams of hydrogen cancel out. Moles of hydrogen cancel out. Moles of ammonia cancel out. We're now left with our liters. Let's simplify. Let's go ahead and bring the numbers down. So we have 30 times 2 times 22.4, all divided by 2 times 3. Okay, let's simplify. 2's cancel out. 3 goes into 30 10 times. So what we really get is 10 times 22.4. So we get 22.4 times 10. We're going to just move that decimal over. 240 liters of NH3. So definitely multiple steps. And by the way, the problems are going to should get a little bit more complicated like this. And that they're complicated, it's just there's more steps involved. So got to balance an equation. Got to do inventory in order to balance it. Got to figure out our coefficients. Those coefficients are going to play a major role in changing from one compound to another compound through a multiple ratio. And then we can do a regular dimensional analysis and figure out our problems. Remember, always have a number, always have the unit, And in this case, because we're dealing with chemicals, you need to have the chemical as well.